Bonjour et bienvenue à ce webinaire. Je me présente, je suis Michel Dufros, donc de la société BDT, et je suis responsable pour le développement commercial de la société Casinta de la promotion pour le logiciel e-Residue. On va un petit peu modifier notre agenda tel qu'il était prévu aujourd'hui. En fait, nous avons avec nous Destin LeBlanc, qui est un peu une sommité en fait dans tout ce qui est la validation des produits pharma, et donc il va, pour des raisons personnelles, commencer sa présentation. Je vais juste switcher en anglais en premier lieu, puisque cette partie-là sera en anglais. Puis ensuite, on fera la présentation du logiciel, elle qui sera en français. So we are pleased to welcome Mr. Destin LeBlanc, who must, however, attend another meeting. We are therefore amending the schedule as follows. First part of the presentation by Destin LeBlanc, which will last 15 minutes to present the indicators calculated for the Casinta e-Residue software. In the second part of 11 minutes, present of the software and the web-based access. And finally, a last part dedicated to questions and answers. To recording of this webinar will be sent to you if you are not attendee, and of course, we are able to continue with you in your organization in order to answer the specific needs in the next days. Destin, this is your turn.
Okay, welcome to everyone. The portion that I'm going to be presenting is just going to be basically on limits calculations principles for actives and for cleaning agents in the e-Residue program. And it's sort of preliminary to understand, so that when Ravi later on takes you through some of the slides, you'll see the way we express limits and make it easier for you to understand. Now, certainly, if you want to call limits something different than what I do, but I try to do it in a simplified way that is not attached to any one way that a company may do it. So with the next slide, there's different ways we can talk about a limit. We can talk about let's go to the last item on this slide. That is the concentration in the rinse water. Sometimes we say, oh, what's the limit in the concentration in the rinse water? So that's one way to talk about it. Another way, and that's what I call L4C, typically in units like micrograms per milliliter. Going up on the slide, L4B is the concentration in the swab extraction solution. Typically in micrograms per milliliter or micrograms per gram. So it's a situation where when you do swabbing, you take the swab and you put it in a vial with liquid, and then you're measuring the concentration in that liquid. And so some companies express limits in that way. That's L4B. L4A is also for swabbing, but it's the amount per swab, typically micrograms per swab. So it's what I call L4A. So it's related to the concentration in the swab extraction solution, but it's the amount, the total amount. So the units are just micrograms. Then going up on the slide, we can talk about the limit per surface area of the cleaned equipment, typically in micrograms per square centimeter, is what I call L3. And then we can go further and talk about the total amount that's allowed in the manufacturing vessel train. In other words, not just the amount per surface area, but takes into account the total surface area. And typically units for that are units like milligrams, could be micrograms, but there'll be a very large amount of micrograms, but it's what I call L2. And then going up the next step is the concentration of the residue that's allowed in the next product, typically in micrograms per milliliter for liquid products, or micrograms per gram for solid products, and it's what I call L1. And then at the very top is L0, which is the daily amount allowed, typically in micrograms or milligrams. And it's the sort of the safe daily amount that is allowed. Now, next slide. The L0 has been called a variety of terms by people in the industry. Sometimes people call it the acceptable daily intake. Some people call it the acceptable daily exposure. Some people call it the safe daily intake. Some people call it the safe threshold value. A lot of people call it permitted daily exposure, or lastly is health-based exposure limit. So it's basically an expression of how much somebody can take every day for the rest of their lives and it be a safe amount that they can take. Typically, the values that have been used for L0 before 2010, we would almost universally use 1/1000th of the minimum daily dose of the active. Starting at around 2010, people started saying, "Oh, let's take a look at specific toxicological information." In other words, we're not going to take a look at the therapeutic dose. We're going to take a look at toxicity studies. And so they talked about doing an ADE or a PDE or ADI, something like that, based on toxicity information. So in the software, the user of the software can select which to use, or it can select the most stringent of the two. In other words, I'll say, I'm going to calculate both of them or enter data for both of them and allow the software to pick the most stringent of the two. Because if you're meeting the most stringent of the two, then you're meeting both the 1/1000 dose criteria as well as the ADE or PDE criteria. So next slide. The L1 is the concentration in the subsequent product. So that safe concentration in the next product, not the safe amount. Safe amount is L0, but the safe concentration is just the L0 divided by the maximum daily dose of the next product. Now, some people choose to use a default L1 value. Typically, for drug product manufacture, it's 10 ppm in the subsequent product. So, in other words, if you're using a default value, generally that's used only if the default value is more stringent than the calculated L1 value. So the software then will enable you to say, okay, we're using a default value, and we're only going to use that default value if it's more stringent than the L1 value based on the L0 value. Next slide. L2 is the total amount in the manufacturing equipment, which is also the total amount in the next product that's made in that equipment. And that's calculated by multiplying the L1 limit times the batch size. Not the batch size of the manufactured product, it's the batch size of the subsequently manufactured product. In other words, not the batch size of the clean product, it's because the batch size of the next product may be smaller. And if the next product is made in multiple batch sizes and you want to cover the worst case, then you want to use the minimum batch size of the next product, because that will result in the lowest limit when the software goes through the calculations. Next slide. Next slide.
Yeah.
L3, gracias. Okay. L3 is calculated just by dividing the L2 value by the shared surface area. And it's the shared surface area of the entire equipment train, not just the one individual piece of equipment that you're cleaning, but it incorporates the cumulative effect. So that if you're making a solid oral dose and you have some blending equipment, you have some uh, uh, filling equipment, it's considering the entire surface area. Now, when people use an L3 value, some companies, not all, but some companies will select a default L3 value, such as 4 micrograms per square centimeter. Sort of what is the, what can be considered, oh, if you're above 4 micrograms per square centimeter, clearly the equipment is going to be visually soiled. So it's an option that you can select. And it's only used then in the software program if it's more stringent than the calculated value. In other words, if you do the calculated value based on the L0 and L1 and L2 and L3, or L2, then, and that's more stringent, then that's what the software selects. Next slide. Now we're getting to the very practical situation in terms of the analytical values that you would get from the swab and rinse. So these are my L4 values, and the limit per swab is L4A. So the amount per swab depends on the L3 value, the limit per surface area, times the swabbed area. Now the swabbed area is the area that you do on an individual swab. You know, typically 10 square centimeters, typically 100 square centimeters, the 10 by 10 swabbing area, or some 25 square centimeters, 5 by 5. So, and basically L4A is calculated just as the L3 value times the swabbed area. Next slide, please. Now we're going to get to the, when we take that swab and we want to place it in a vial of liquid solvent and extract it, and then send that to the analytical laboratory for testing. That concentration on the swab extract depends on the limit per surface area, the swabbed area, and the amount of solvent that's used for extraction. So it's calculated just as the L3 times the swabbed area, which is essentially L4A, and then that's divided by the swab extraction amount. In other words, are you extracting it in 10 mLs or 10 grams of solvent or 5 grams of solvent? That type of expression of the solvent extraction amount. Next slide. And now we go to the limit in the rinse sample, where typically in my publications, I express it as L4C, and that's the basic value basic descriptor that's used in the software. So that concentration depends on the L3 value, because the L3 value is independent of whether you sample by rinsing or swabbing. So it's the L3 value, the area that you're rinsing, and the rinse volume. And so that's calculated as L3 times the area rinse divided by the rinse volume. So you can see actually when the calculation is very similar to what is done for swabbing, it's just the area rinsed is a much larger area than the small area that's used for swabbing, and the rinse volume is much larger than the small volume of solvent that's used for a swab extraction. So this enables you to get different ways to express what limits. Next slide. Now the question is, you may want to ask, you know, why do I want to do all these things? You know, I only, in the way we do limits in my facility, we only calculate the amount per swab, okay? Now, the software will calculate all value, but the user can select which to include in the report. Now, any can be used as the ultimate limit for a protocol, but sometimes you want to be aware of what those values are. For example, the L0, which is the basic safe daily amount, you certainly can use that to compare your dose-based limit to the health-based limits, because both of them are L0 values, and you want to pick the most stringent. Sometimes it's useful to know what the L1 value is, because you're comparing that to the 10 ppm default value if you're using a 10 ppm default. It can also be used not in a cleaning validation protocol, but if you're doing a placebo sampling or blank run. The relevant limit there, because you're actually measuring the residue in the next product, is the L1 value, because the L1 is the concentration that's allowed in the next product. L2 is something that may be important if you're taking a look at total carryover. In other words, you're taking total carryover, you're using what I call a stratified sampling approach, and sampling different pieces of equipment or different areas on the equipment and want to integrate them together to get a total carryover. L3 is important in terms of whether if you're going to use a default for micrograms per square centimeter, for example, that's typical visual limit, and you want to determine which is the most stringent. And the L3 is also typically used when you're doing sampling recovery studies for how much you want to spike onto the coupon to represent what could be present at the limit, the maximum amount that could be present on your equipment in a cleaning validation protocol. And then the L4B and L4C are useful for determining the linear range that you want to have for your analytical method validation. In other words, for your analytical method validation, you want something it can measure below your L4B or L4C. And so you want a linear range below those things. So it helps you to set up an appropriate linear range for analytical purposes. Now, I'm going to switch gears slightly, so next slide, and talk a little bit about another feature of the software, and that is to help you do grouping. And ordinarily, when you do grouping, and we're going to talk about grouping for different products, what you're trying to do is to simplify validation by saying, I'm going to take a look at all the products that are made on this particular piece of equipment, and I want to pick the representative product. The representative product is the most difficult to clean product. Now, sometimes people call that the worst case product, and that's another way to refer to it, but I like to refer to it as generally we pick the representative product because it's the most difficult to clean. Now, how do we pick the worst case product? Well, different companies pick it different ways. Some people take a look at the solubility data of the active alone. Some people will actually do lab or pilot studies and compare products in a lab study. Other companies will have some kind of point system, and we'll talk about what typically is in a point system to evaluate different characteristics of the products and to get a sort of an overall picture of what makes something difficult to clean. So next slide. In the point system, they rate various characteristics of the different products on a scale. So there may be a scale that talks about the solubility of the product. There may be a scale that talks about the solids of the product. In other words, here again, the other things being equal, the less soluble the active is, the worst case it's going to be. The other issue is that the more residue that's left on the, more soil is left on the equipment to be clean, the more difficult it is to be clean. Viscosity applies to ointments, so more viscous products are going to be more difficult to clean. Miscibility with the cleaning solution. If it's completely miscible with the cleaning solution, it's easier to clean. If it's not miscible with the cleaning solution and it operates by suspension or solubilization or emulsification, then it would be considered more difficult to clean. Toxicity is something that is, it's not really difficulty of cleaning, but it's something that means that your limit is going to be lower, okay? Cleanability is maybe some kind of lab study that people do, and some people may include issues, things like dyes or fragrances that not necessarily make it more difficult to clean, but add another element to the system. And so what they will do in this point system is next slide is they will decide on a weighting factor for each parameter. For example, solubility, it's got to be rated perhaps, on a scale, but then the scale of the solubility may be 1 to 5, 1 being easy to clean, 5 being worst case, most difficult to clean, whereas the weighting factor that's used for dyes and fragrances may only result in a scale of 1 to 2. In other words, solubility of the active is more important than the presence of a dye or fragrance. So each of those factors that you select, and you can select the factors that are appropriate for your particular products, and then the ratings for them are either multiplied together or added together to rank each product, and the product with the highest number, either by multiplying everything together or adding everything together, is the worst case, assuming that higher numbers are a greater risk. Next slide, there's an alternative to that basic point system that historically has been used, and that is to use a staged or stratified point system. So they still select the relevant parameters, but then the next step is determine the criticality of each parameter. In other words, which parameter is most critical at the top to the parameter that's least critical. And then each product then is rated by the most critical parameter. That is parameter number 1. If one product is clearly the worst just based on that one parameter, then you stop and you don't go further. If there's 2 or more products that are the worst case by that parameter, then you go to the second parameter and do a comparison. And if there's one product that drops out, that is the most difficult, the worst case, then you stop. That's the worst case. That's your representative product. If there's more than one product that are the worst case by that second parameter, then you go to the third parameter. So you continue until there's one worst case, or until you've determined that 2 or more are equally worst case by all parameters. So let me, next slide then. Here's a simple example of stage system that could be used for injectable products, where essentially all your components are more or less water soluble. So the relevant parameters may be solubility of the active. That's probably the most critical. Number 2 would be the concentration of the active. Here again, the more active that's left behind on the system, the more difficult it is to meet your acceptance limits. And then the third most critical is the total percent solids of the products. Now these are merely given as an illustration, but the idea is that we would take all our products and take a look at the solubility of the active, and if one drops out, we would then use that as the worst case product. If 2 or more were the worst case by solubility, then we would go to concentration of the active. So let's go to the next slide, and the final slide, and that is, once we end up with a worst case product by the grouping approach, now we need to go back and say, what is the limit for that worst case product? And this goes back to the earlier slides that I have where we pick the worst case, because we're going to pick the limits. We're going to calculate the limits for every product in the group. In other words, each product in the group is going to have a limit. Then when we pick by the point system or by the stage point system or whatever system we use for picking the worst case product in a grouping approach, then our protocol is going to be on that worst case product, and we're going to use as the limit for that worst case product, not necessarily the limit for that worst case product, but the lowest limit for any product in the group. That's going to be used for the protocol in the worst case product, because this gives us an assurance that if we can meet the lowest limit on the most difficult to clean product, then we've covered and we will meet limits for all products in the group. So with that, I've ended my formal presentation. So I'll turn it back over to Michel, and he will continue with the webinar. You're silent. Michel, you're silent. You need to unmute your microphone. Michel, unmute your microphone.
Oh, thank you, Destin. Sorry. Thank you, Destin. Thanks for the reminder and explain what the e-Residue software will calculate for all the users. And thanks for your presentation. Avez-vous des questions, s'il vous plaît? Est-ce qu'on m'entend? Oui, c'est bon. Vous m'entendez? Ah, Alice. Alors, ça c'est une question pour Ravi. Ravi, is the system is able to generate a protocol, a complete protocol for the team, to cleaning team?
Exactly. It generates, it takes your current protocol. You can set it up exactly the same thing inside the application. The main advantage of doing that is that no more do you need to collect all the data. It will all be there within the software. So all you have to do is create the template once, and the application then creates this protocol for you every time automatically.
Ok, donc le protocole, hein, le système permet de générer en fait un protocole complet pour les équipes et ça tout le temps d'un quelques clics et il faudra préalablement bien évidemment entrer les paramètres que vous avez pu voir à l'intérieur du système. Y a-t-il une autre question? Bon. Pour le moment. Ok. Ah, Alice, oui. Tac, tac, tac. Oui. Donc, Alice. Ah, Ravi, it's still for you. Does it possible to upload all the equipments via an Excel sheet directly in the system? Yes.
No.
No?
No.
Okay.
The reason
No.
why we cannot do that is because the locations where we need to identify where you're going to sample, all of that
Okay.
needs to be uploaded. So what we do is we give you an Excel sheet, and you can fill up the Excel sheet, and we have a software which then uploads it for you.
Ok. Ok. Donc,
It's not
Alice,
a direct customer-based upload, Michel.
Ok. Alice, donc le fichier, un fichier fourni en fait par Cassenta, et vous le remplissez en fait, et à partir de là, de ce fichier où tout est parfaitement identifié, les éléments peuvent être directement uploadés dans le système. Voilà. Merci à vous, Alice. Écoutez, s'il n'y a pas d'autres questions pour le moment, je vous remercie d'avoir participé à ce premier webinaire. Nous en referons un deuxième, hein, de toute façon, au courant du mois de juillet. Ravi, thank you.
Thank you, Michel, for
this first webinar, not the last one. And yeah. And
thank you for the participants for
yes,
joining in, and appreciate your questions.
Thank you, Destin, for your collaboration and for your presentation. Donc nous referons ah, merci Sandrine pour votre présence. Bien évidemment, hein, on reste à votre disposition pour étudier avec vous les besoins dont vous auriez à l'intérieur de vos organisations. Le but est vraiment que vous puissiez gagner du temps et de gagner en qualité en interne sur la production pharma, bien évidemment. Voilà, on vous fera parvenir les éléments du webinaire, notamment avec les éléments de Denis, de Destin, excusez-moi, concernant les différentes limites à prendre en compte et que le software e-Residue vous permet de faire. Voilà, je vous dis à bientôt. Merci à tous et à toutes et à très vite pour un nouveau webinaire.